Checking over our vector addition worksheet, specifically question number 16. We got these four vectors here. We got 10 meters, then we got 10 meters, and then we got 5.0 meters. It's kind of hard to read that, but it looks like 5.0 meters at 60 degrees. That would be 60 degrees, by the way, east of north, because that angle is measured from the north, east of north. And then we have 20 meters at 30 degrees south of east, because it's measured from the east or of the east. We get two funny angles here, and we know what to do, right? When we see a funny angle, we say, I don't like funny angles. We take them off to the side. We get rid of the funny angles so that we never have to deal with it again. Let's do that now. The first funny angle is 5.0 meters at 60 degrees. So let's draw that right here. 5.0 meters at an angle of 60 degrees from the vertical or from the north, east of north. Okay, let's draw a triangle around it. This is what we do, right? We draw a triangle around it with an X and a Y. Now, X is which side of the triangle? That's what I want to find here first. So which side of the triangle is that? Is it opposite, adjacent, or hypotenuse? Opposite. The hypotenuse is the 5. The hypotenuse is the longest side, always. Okay, the hypotenuse will always be the longest side. And the other side that's touching the angle, the short side touching the angle, is the adjacent, and then the side that's not touching the angle is the opposite. So that is opposite. If we're looking for x, we're looking for opposite. We have the hypotenuse. Opposite and hypotenuse goes with which trig function? Sine. So sine is equal to opposite of hypotenuse, ka toa. So we'll say sine 60 degrees is equal to opposite over hypotenuse. X ends up being equal to 5.0 times sine 60, which I believe is 4.33. And then we're going to say cosine 60 degrees is equal to y, that's the adjacent side, over 5.0. And this one's easy. This one just works out to be exactly 2.5 meters. So I'm going to block that off, because that's what I do, right? I block off my little angle analysis there when I don't like my funny angles. And then I go back and kind of fill in, change my diagram a little bit, to look a little bit simpler with my new vectors. I don't like that 60 degrees, so I get rid of it. I'm going to label this now as 4.33 and 2.5 up. And I'm going to try, at least, see if this works. Yeah. I'm going to get rid of this. It's gone now. I replaced it with a 4.33 and a 2.5, and I don't ever have to worry about that 5 meters at 60 degrees now. It's completely gone forever. Replace it, and it's gone. Now, I do have one more funny angle that I'm going to take off to the side here. That's 20 meters. I'll make it a little shorter, though. It's 20 meters at an angle of 30 degrees here. I'm going to do this one in blue, just so you don't get confused, hopefully, with which one we're dealing with here. Okay, this is, of course, my x. This is my y. Now, the x side of the triangle is which side? Is it opposite, adjacent, or hypotenuse? It's adjacent. So we're going to say cosine 30 degrees is equal to adjacent over hypotenuse. 20 times cosine 30, I believe, is 17.32. 17.32, is that right? And then we'll say sine 30 degrees is equal to opposite over hypotenuse. Opposite is the y side, because it's the one that's not touching the angle, right? X was the adjacent side, because it was the short side touching the angle. 20 is the hypotenuse, because it's the longest side. And the y component is the opposite, because it's not touching the angle. Y ends up being equal to exactly 10 here. So let's box this one off as well, just because it's kind of separate from the rest of it here. And now let's replace this 20 meters with these two new vectors, 17.32 this way and 10 this way. And let's do some erasing here. It's gone, right? It's completely gone. If you want to redraw it or whatever, okay, because you can't erase it that's on your worksheet. Do whatever you have to do, but in the end, or just kind of scribble it out or whatever. But you can see here now that I got a pretty straightforward question now, right? Once I get rid of those funny angles, I get a pretty straightforward question. And also notice that my original diagram, I didn't do anything on that. When I did my analysis to find x and y, I did it off to the side. Now I came back and I replaced those vectors, right, and I redrew it, but I didn't do my work on there. I did my work off to the side. If you start doing your work on the original diagram, there's a good chance you're going to get confused. There's a good chance you're going to get messed up. So take it off to the side like I did right there. Okay, the first one that I replaced is in green. The second one that I replaced is in blue. Now I just do my x and y components. How much of the first vector is x? That 10 meters. Negative 10, because it's to the left. How much of it's y? 0. Second one, 10 meters going down here. How much of that's x? 0. How much of it's y? Negative 10. Third one, how much of it's x? 4.33. How much of it's y? Some people will say 0, because look at that, 4.33, and it's not going up at all. Okay, I'm going to actually combine those green ones and say 4.33 and 2.5. Does that make sense what I did there? Okay, you could absolutely say 4.33 and 0, and then 0 and 2.5. Okay, that would be the same thing. I'm just kind of doing it all together there. Actually, I'm just going to erase that and put that in green just to kind of point out where it's coming from. Now, what about the next one? What's the x component of the next one? 17.32. What's the y component? Well, you could say 0, and then say 0 and 10, or we can just say 17.32 and minus 10 there. Make sense? Your choice, doesn't really matter. Okay, the way that I've done it saves a tiny bit of space, but not really any work. Add these up. 4.33 and 17.32 is 21.65. Subtract 10 is 11.65. Is that right? Negative 10, 2.5 gives me negative 17.5. And now we redraw it. We have 11.65. And we have 17.5. And my resultant vector is drawn right here. My resultant vector is which side? Opposite, adjacent, or hypotenuse? Hypotenuse. And I'm going to draw my angle where? Position 1, 2, or 3? 1, 2, 3. Position 3. Always drawn at the start of the vector diagram. So we're going to find the value of r by doing the Pythagorean theorem. So 11.65 squared plus 17.5 squared. Who has a value for that? Okay, we'll do that on the calculator then. Or maybe not. Or not, okay. We get 21.01, or we'll just round that to 2 digits, 21 meters. And theta is equal to the inverse, which trig function? Which two sides of the triangle did we have at the beginning here? 11.65 is the opposite or adjacent or hypotenuse? Adjacent. Okay, r is the hypotenuse. 11.65 is the adjacent. It's the short side touching the angle, and opposite is the 17.5 there, right? So we're going to say it's the inverse tan of 17.5 over 11.65. And what do we get for that angle? 56 degrees, thank you. 56 degrees. And what are we going to make that? 56 degrees what of what? South of east, right? Okay, we're measuring the angle from the east, right? So it's south from the east. If you look at this, whoops. We're going east, we're going south, but the angle is measured from the east or of the east. So south from the east or south of east. Listen, if you didn't get it, that's fine. Okay, copy it out. If you just didn't do it because you just didn't see fit to do it, all right, it's a new day. Copy it out.